Hi, 6th grade. This is lesson 2.1, Find and Apply LCM and GCF. I can find and use the GCF or LCM to solve problems. This lesson has lots of vocabulary in it from your notebook that you filled out. Hopefully you remember that a multiple of a number is the product of a number and any number except 0. So multiples of 2 is when we count by 2, so it's like skip counting. So multiples, 2, 4, 6, 8, etc. Okay, multiples of 3 would be 3, 6, 9, 12, etc. All right, a least common multiple is the least number that is a multiple of 2 or more of the numbers. So if we were looking at these two numbers, we would see that these both have 6. So their LCM is 6. Multiples, remember, are like skip counting. Okay? All right, let's jump into our lesson. 3 runners leave the starting line at the same time. Lena runs each lap in 3 minutes. Arya runs each lap in 5 minutes. And Tran runs each lap in 6 minutes. When is the first time in minutes that all 3 runners will cross the starting line together? There's going to be a lot of word problems on this lesson. I want to note as we go what they're asking us to find. So I want you to notice in this problem it says at the same time. That is super important to note when you're reading. Then it says cross the starting line together. Okay? When you see at the same time and together, I want you to make those jump out at you instantly. At the same time and together. When you see those, you are going to find LCM, and I want you to write LCM on your paper. All right, so let's work through this on the next. All we've done is read it. So now it says, how many minutes does it take Lena to run 12 laps? So she's running 12 laps. How many minutes per lap does Lena run? 3 minutes, correct. So 12 times 3 is 36. So it takes her 36 minutes to run 12 laps. So we're going to complete the table. Now this is like what I was doing before. This is a table form, but again, it's just like skip counting. Look at Lena. 3 times 1 is 3. 3 times 2 is 6. Okay? So what's our next multiple? 3, 6, 9. Then, good, 12, 15. Yes, 18. 21, 24, 27, 30. Nice job. So we just wrote out the multiples of 3, guys. It's in a fancy table, but that's all we did. Let's do 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, I want you to pause the video and do the 6s. So you did 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. Okay? So basically all we've done so far is list the multiples. So we're finding LCM. And the first step is we listed the multiples. Okay? Then it says, look at the results in the table. What do you notice about the times in each row? So you notice that they're getting larger and they're increasing. Look at the rows for the 3 runners. Do they have any time in common? Do they have any times in common? What do you notice? Ooh, I found one. 30. Do they have any other times in common? So you can have many common multiples. just usually we're looking for least common. All right, so the one they have in common, I think that's the only one, is 30. The first time in minutes that all 3 runners finish a lap at the same time is the least common multiple of their times. That is so important. I want you to take your pencil and draw a circle around that. If you have a highlighter, okay, remember I said at the same time is least common multiple. You have to remember at the same time LCM, okay? So 30 is the least common multiple of 3, 5, and 6. All right, we're going to switch gears and talk about factors now. So I'm going to looking at this yellow box, connect to vocabulary. It says, you know that a factor is a number that is multiplied by another number to get a product. So if we use the number 36, 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. And 6 times 6 is 36. So what I did, I taught 5th grade, they learned to do factor rainbows. I don't know if that's what you all did or not, but notice that I drew my rainbow so I knew which ones connected to each other. And since I started with 1 and worked my way in, once I got to the middle, 6 and 6, I know there's nothing between those, so I'm done. Okay, so those are factors. What times what equals the number is the factor. We could also, let's try it with the number 12. So 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Again, there's no numbers between 3 and 4, so we know we're finished. All right, so we've listed out factors using our factor rainbow, and you don't have to draw the rainbow. It's just the way I like to do it so I don't miss any. And then you can look at them and you can find the ones that they have in common. So notice that they both have a factor of 1. They both have a factor of 2 and 3 and 6 and 12. There's plenty of common factors here, but remember we want the greatest common factor. So the one that is the biggest that they have in common is 12. So the GCF would be 12. So you have a quick review before we jump into the word problems. All right, so number 2 says, Taylor and Jake are in charge of bringing snacks for their chess club. They have 24 granola bars, 16 water bottles. They want to set out the snacks so that the snacks are distributed evenly in snack packs with no granola bars or water bottles left over. What is the greatest number of snack packs that Taylor and Jake can make? Okay, so our keywords on this one is what are the greatest number that they can make. Anytime you see greatest number that they can make, that hints to you that we're going to find GCF. Okay. Complete the tables to find the possible numbers of snack packs and numbers of granola bars and water bottles in each snack pack. Okay, so we had 24 granola bars. So if we made one snack pack, we would have 24 because 1 times 24 is 24. 2 times what is 24? 12. So if we made 2 packs, both packs would have 12 in them. So then 3 times 8. If we had 3 packs, we'd have 8 in each. What times 6 is 24? 4. 4 times 6 again. 8 times 3. 12 times 2. And 24 times 1. So what these mean is the number of packs we have and the number of granola bars. Let's say we decided to make 4 packs. If I had 4 sacks of granola bars, each one would have 6 in it. Okay, so that's what that means. Let's look at the water bottles. 1 times 16 is 16. 2 times 8 is 16. 4 times 4. 8 times 2 and 16 times 1. So basically what we've done in these tables is the rainbow like I did, only you have to remember they can go both ways. So So you have to get all of them in there, okay? So again, on this section, if we had 4 snack packs, we would have 4 water bottles in each one, okay? In the first table, the number of snack packs and the number of granola bars per pack were factors of 24, because that's how many we had. In the second table, the number of snack packs and the number of water bottles per pack were factors of 16. They told us we had 24 granola bars and 16 water bottles. That's where I got those from. Using the tables, list all possible number of snack packs for each item. Okay, so we could have 1 snack pack, 2, 3, 4, 6, 8, 12, and 24. All I did was look at this box right here where it has snack packs, and I wrote those down. Okay. For the water bottles, here's our snack pack column. 1, 2, 4, 8, and 16. These right here are our factors. Okay, that's what I did before. I made my rainbow. These just don't have the rainbow. Okay, those are our factors. What numbers are in both lists? Let's see. Which ones are in both? Well, they both have 1 and 2, 4 and 8. Okay, 1, 2, 4, 8 are in both lists. What is the greatest number of snack packs a volunteer can make? Well, these are the common factors. They could make 1 big bag of snacks. They can make 2 bags of snacks, 4 bags of snacks, or 8 bags of snacks. But what's the greatest one? So that's the GCF that they're asking us for. That's 8. So the greatest common factor of 24 and 16 is 8. You can use the greatest common factor to write the total number of water bottles and granola bars, 24 plus 16, as a sum of products. Okay, so the number of snack items equals the number of granola bars plus the number of water bottles. So we said that we were going to make 8 packs. So we'll put the 8 on the outside. If we look up here, we have 8 and 3 and 8 and 2. So we'll do 8 times 3 and 8 times 2. Does 8 times 3 give us the 24 granola bars? Okay. And does 8 times 2 give us the number of water bottles? Yes. You can use the distributive property to write the number of snack pack items as the product of the GCF and another sum. Okay, so this is a little confusing, but what we're going to do is we're going to take what we just did, so our 8 times 3. Those were our factors that we used to find the greatest common factor, and 8 times 2. Now, you'll notice that there's an 8 here and an 8 here. Was 8 our greatest common factor? Yes. So the greatest common factor is going to go outside of those parentheses. Then our other 2 numbers will go inside there. Okay? And then I think you've learned about order of operations, where you do the parentheses first. So it's 3 plus 2? 5. So we have 8 on the outside. So there are 8 times 5 snack items. All right, the next page says, which is greater, 5/6 or 7/10? Complete the list of multiples of the denominators. All right, so 5/6, they want the multiples of 6. So 6, 12, 18, 24, 30. And then they want the multiples of 7/10 denominator, which is 10. So 10, 20, 30, 40. The least common multiple of the numbers in the list is. So look at them. What's the least common multiple that they have in common? I see it's 30. Rewrite the fractions using the LCM as the common denominator. So that says they're saying that 30 should be our denominator. 6 times what is 30? Times 5. So we'll do 5 times 5 is 25. Remember, whatever you multiply the denominator by to get the common denominator, you're going to also multiply the numerator by. And remember, it's numerator over denominator. So 10 times 3 is 30, so 7 times 3 is 21. Use the new fractions to write an inequality to compare the original fractions. So we have 25 30ths and 21 30ths. Which one's greater? The 25, so it'd be like this. So 5/6 is greater than 7/10. So if you find a common denominator, you can compare them a lot faster than trying to guess the set 5/6 and 7/10. It's kind of like what we did at the beginning of the week when we put them on the number line. We gave them common denominators to figure out where they would go. All right, let's try one more, this time with some negative denominators. Same idea. Which one is greater, negative 13 24ths or negative 7 18ths? Complete the list of multiples. So just like before, I want you to pause this time though and write out your multiples. All right, so check your work and see if you have the same multiples as I do. Then B says the least common multiple of the numbers is. So we're looking for the least common multiple. I think it's 72. Okay, so then rewrite the fractions using the LCM. Okay, they didn't give us any space for that this time. I don't like that. So negative 13 24ths, and it's going to be over 72. And then negative 7 18ths, and it's going to be over 72. And just keep those negative signs. Okay, so 24 times what is 72? Times 3. And so 13 times 3 is 39. Remember, you have a calculator on your computer or on your phone, or if you have a calculator, whatever works for you. All right, and then 18 times 4 is 72, and 7 times 4 is 28. And we're just keeping those negatives because our fraction started out negative, okay? Okay, so our new fraction is 39 over 72, negative 39 over 72, and negative 28 over 72. So which one's greater? Okay, remember these are negative, so we have to think about, which one's closer to 0? The negative 28, so it's bigger, which means the negative 7/18 is larger than negative 13 over 24. So although with the negatives, it takes a little bit more thinking to compare them, it's the same process. When you're trying to compare fractions, find a common denominator and then compare them. You can use LCM to help you find the common denominator. You could also do it your own way, but just remember, if the book asks you for the multiples, well, how to do it, okay? If it just says compare them, you can do it your own way. All right, so we're gonna skip D. I will see you soon.